Welcome to the SEACO-GULF OpenFOAM tutorial series. In this first episode, we will explore one of the most popular beginner simulations in OpenFOAM, the lid-driven cavity flow. By the end of this video, you will know how to set up, run and visualize the CFD case using OpenFOAM and ParaView. Alright, so let's start the tutorial. Before that, let me tell you something about lid-driven cavity. So the lid-driven cavity flow is a classic CFD problem where we have a square cavity filled with the fluid. The top lid moves at a constant velocity which causes the fluid inside to circulate. It's simple to set up but rich enough to understand the fundamentals of OpenFOAM. Alright, so let's start and then we will see it visually also. Alright, so here is our case of cavity. Okay, it is there. So how to run it? Okay, so in OpenFOAM tutorials you will find all run file. Okay, so there step by step all the commands are given, but that is not a good practice. Okay, because when you are making your own case, you will not be able to run it step by step. Okay, so not to use all run. Okay, so in our case, and we will go into the tutorial and in the foam tutorials, in the OpenFOAM tutorial, and you will find the cavity all run is not given. Okay, so how to run it? So we will first go inside the system to check the dict files, how many dict files are given. So there is one blockMesh dict file is there, and there is decompose par dict file is there. So blockMesh dict is for making the mesh, decompose par is for making the for running the simulation in parallel. Okay, so yeah, so first you now from here you can, by seeing the dict files, you can get that okay, what are the commands I have to run. Okay, so first we have to run blockMesh, then we have to run decompose par, and then after that we have to run the solver, okay, which is icoFoam in the case of the cavity. Okay, so first we will run the blockMesh. Okay, the mesh has been made, so let me clear the case. Okay, mesh has been made. To check it, you have to go inside the constant folder, and here you can see a polymesh directory has been made. If you have not run the polymesh the blockMesh command, the polymesh directory will not be there. Okay, let's go back. Now we have to run it parallelly, so we have to go inside the system, and we have to go inside decompose par dict. Okay, so here I have made the changes beforehand, but initially the number of subdomains were given as 9 and here it was given as 3 and 3. Okay, but I have only 4 number of cores, so I have to keep it 2 and 2. Okay, so if you wanted to change the number of cores according to your workstation, you have to make the changes here. So first you have to specify how many number of cores of your workstation you are going to use, then in the coefficients you have to change the things, all right, accordingly. Okay, yes, so let's save it and go back, and then we will run decompose par. Okay, so that is ran. Now let's clear it. Okay, and then we have to run it parallelly. So this will be the way of running it parallelly. So -np4 icoFoam parallel. Okay, and press enter. So you can see that it is running, and now the simulation has been complete. Let's clear it. Okay, let's clear it, and if you can go inside the processor 0, you can see that all the files has been written. So I want these time steps outside. Okay, because some of the things have been solved in this processor, some of the things have been solved in this processor, some of the things here, some of the things here. So we wanted to club it and make a single time step file. So this, how to do it? Use this command reconstruct par minus time 0.1 to 0.5. Okay, yes, here it is. Okay, you can see that all the things have been clubbed and written here. Okay, so now we have to go to ParaView. So before going to the ParaView, you have to make .foam file. So I'm making it with the help of this command touch. Name you can only give, you can give anything like 1.foam, 2.foam, a.foam, b.foam. I'm giving foam.foam because like I use this only. So that has been done. Now we will go to paraview.exe, foam.foam, okay, and press enter. Right, it will take, yeah, it is open now. Just maximize it, press apply, and here you can see our simulation results. Okay, so first let's go to solid color and check our domain. So this is our domain, this is our square cavity. Okay, so this is the top portion which is being moving with the constant velocity. So let's see the velocity. Okay, so this is the velocity. All right, so how you can visualize the circulation? So for that we can use this streamline option. Use this stream tracer, and I'm going to use the point cloud. Okay, so it is like giving like this. I'm going to increase the radius to 0.03. okay, 0.03. okay, or let's increase it more, 0.05. okay, yes, it is now covering much more area. Okay, and in the z direction we can keep it it's coming very big. We'll keep it 0. No. Okay, yes, yeah, let us keep it like this. Okay, and press apply. So here you can see, if I'll hide the point cloud, you can see that these streamlines. Okay, so it is like in the circulation part. So basically, as I have told you, what is the lid driven cavity flow is like the the fluid inside, movement of the top portion make the fluid inside to circulate. So the fluid is circulating like this. You can see, yeah, it is not much, like it is like some settings you have to do that we will do later on. But yeah, you can find like, okay, it is clearly visible that how the fluid is circulating. Okay, fluid is rotating. Okay, so yeah, this is the tutorial of the cavity flow. Okay, yeah, and that's our first OpenFOAM simulation. In the next episode, we will go deeper into customizing meshes and boundary conditions for more complex geometries. Don't forget to subscribe so you don't miss it.